So today we're going to start with the exponential unit. So there's exponential and then we still have one unit that we need to finish, which is trigonometry. So with the exponential, we're going to start with the exponent laws. So there's different laws that we're going to be using in order to be able to simplify exponents. Okay? So the first law, so what we're going to do, we're going to explore it first. So we're going to see what's happening before we come up with a law. So if you're looking at a to the power of 4 times a to the power of 5. So remember that in order for exponent law to work, you must have the same base. So when I'm talking about a to the power of 4, for example, the base is a, and the exponent is 4. Right? Yeah. So when I'm multiplying a to the power of 4 times a to the power of 5, my base is a for both of them. That's right. Right? So if the bases are not the same, you can't use these laws. So if let's say this was a to the power of 4 times the power of 5, you can't do that. This law doesn't exist, doesn't work. They have to have the same base. Now let's see what happens. A to the power of 4 means what? How can I expand a to the power of 4? What does it mean?
A times A times A times A.
That's right. So a times a times a times a 4 times, right? And then I'm multiplying by a to the power of 5. So that's another a to the power of, that's a times a times a times a times a, right? So I have a times 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 a, which is a to the power of 9, right? So I'm multiplying a 9 times by itself, right? So if I have a to the power of 2 times a to the power of 4, that's the same thing as writing a times a, and then times a times a times a times a. So that's a how many times?
8. 6 times.
That's 6, right? So 1, 2, 3, 4, 5, 6. So that's a to the power of 6. If I have a to the power of 5 times a, so that's going to be a to the power of 6. Right? Because I have power of 1. Can you guys tell me what would a to the power of 6 times a to the power of 2 be? A to the power of 8. And if I want to expand this, I have to write a 6 times. And then 2 times, so that's a to the power of 8. How about the last one?
7.
A to the power of 7. So what are we doing here? What is the common thing that you're seeing as you're doing this one?
You're adding the exponents.
Adding your exponents, right? So when you're multiplying two exponential with the same base, you just have to add your exponent and that will give you the answer. You don't actually have to do all this expansion. It can be done like that by just adding your exponent. If I do 4 plus 5, that's going to give me 9. 2 plus 4, that's going to give me 6. 5 plus 1, that's going to give me 6. 6 plus 2, that's going to give me 8. Right? So you keep the base the same. The base doesn't change. Right? You add your exponent. So if I have a to the power of m times a to the power of n, what I do is I keep the base the same and I add the exponent. This is the rule. It's called the product rule. Product means multiplication. Okay? So you'll see that the product rule is right here in the blue. Are we okay with this? So the rule to be able to use the product rule is I have to have the same base. Right? If I don't have the same base, I cannot use it. Now we're going to do the same thing, but in this case we have division. Okay? So I have a to the power of 5 divided by a to the power of 4. Same thing, we're going to expand, so we have a times a times a times a 5 times, and then divided by a times a 4 times. So what happens here is, eyes on the board for a second, please. So what happens here when I have division, I start simplifying, so I start canceling, right? So that's 1a, that's another one, that's another one, that's another one. So what am I left with? Just a to the power of 1, right? Or a. So let's do another one. A to the power of 4, so that means I have a times a times a divided by a times a. So what happens if I cancel here? How many a's am I getting?
2a.
So it's going to be a to the power of 2. Okay? What do you think the next one is going to be? A to the power of 4, do we agree on that? So let's see, if I have a times a times a times a times a over a, cancel, only 1, so I'm going to be left with a to the power of 4. Do you see a pattern here? Do you see what's happening? Subtracting what? The exponent, that's right. So you subtract the exponent of the top minus the bottom, right? And you keep the base the same. The base is not changing. So what would this answer be? A to the power of what? If I have a to the power of 6 divided by a to the power of 2.
1.
How about a to the power of 4 divided by a to the power of 3?
8.
A to the power 1, which is 8. That's right. So the rule is, if you have am over an, again, you have to have the same base, then you do a m minus